Thank you for coming. Today we're going to be talking about DigitalOcean and how to scale your startups or your apps on DigitalOcean. This is a 101 level presentation. I'm going to keep it a little high level. I'm going to walk through how you can deploy your applications on DigitalOcean's infrastructure, and then how we enable you to seamlessly scale it up using all of the services that we provide. So my name is Karan Chhina. I'm a product manager for Droplets at DigitalOcean. Droplets is our virtual machine or compute as a service offering. So that's one of our core offerings. DigitalOcean was founded in 2012 in New York City. We've had a fair bit of funding raised. In total, we have over 80 million droplets or virtual machines that have been deployed ever since. Actually, the number is almost hitting 90 million, last I checked. A very big community of developers and teams on our platform. We just hit the 500 employee mark a few weeks ago, so we're growing pretty rapidly and well-funded. Our core tenets are based, we combine the power of open source and we aim to provide really simple solutions to our customers that are supported by a very strong community of developers and a lot of articles on there, a lot of tutorials, et cetera, and then a passion for customer service, very, very strong customer service support. So in today's talk, I'm going to be talking about some of the best practices when building for scale on DigitalOcean's infrastructure, and then also what it takes to ramp that up from that initial deployment, from that initial proof of concept, to scaling for literally millions of users. We have tens of thousands of businesses and hundreds of thousands of developers on our platform that have scaled their apps to very, very large scale. So I'm going to, while I talk about it, I'm going to take an example of an app called SharkTube, and just to showcase how we want to go out to market with something like SharkTube, how to deploy it in the beginning and how to scale it up. It's basically a web app along with a mobile component that enables users to upload Shark videos and then view Shark videos and share Shark videos. This is a very standard web app, as an example, right? So where do we start? So at this point, you're figuring out, okay, I want to get going somewhere. So you go search for different types of stacks or what it is that you want to deploy. So you go and search, you want to install maybe a LAMP stack or a Node.js stack, et cetera. And so what you'll find is as you search for some of these commonly used stacks, DigitalOcean articles come up at the very beginning, very top. We have over 2,500 tutorials and tens of thousands of articles that talk about how to deploy various different types of stacks and applications and software and configure them on the platform. So here you have two options. You can either install the components yourself, or you can go to one of our newer offerings, which is a marketplace. So we provide a lot of one-click software deployments now as part of a marketplace. So let's say you choose that, and it'll take you to the marketplace portal on DigitalOcean, where all of the software for that specific stack is combined together and ready to go as a one-click offering. And so you go ahead and, whether it's a LAMP stack or a Node.js, databases, hundreds of different options out there, you can go ahead and click create a droplet out of it. And what it'll do is it'll take you through the process of creating the droplet. And that's where you will end up selecting the configuration of that droplet, what size of droplet you want. We have 12 data centers in 8 geographical regions. And so you can pick and choose where your audience is. Depending on where your audience is, which regions do you want to set up your infrastructure in? So at this point, this is more or less a single service architecture, or rather a single server architecture. You have all of your components, your entire full stack, your web server, your database, all of that storage that's needed to store all of the Shark videos. By the way, all of our droplets come standard with SSDs. So very high performing storage is included with our droplet instances. And then all of them get a public IP address, an IPv4 address. So you get all of that. It's all set up now. You can deploy, you can copy your code over into the droplet, leveraging the stack that we've just set up. DigitalOcean also provides a DNS hosting service. So you register your domain with the domain registrar, point it to the DNS servers, DigitalOcean's DNS servers, and you have your app pointing to another thing you could possibly do at this point is setting up SSL so that it's secure. You set up your certificates, we make that really simple as well. So now you have this one virtual machine, a droplet, with everything in it to run your application along with the web component, database component, et cetera, for hundreds or maybe even thousands of users. It depends on how much, but this is a very, very initial type of setup. So let's see what else can we do. So some of the post-deploy actions after you have set up that droplet, you want to set up some additional things, things like monitoring. And so we provide inbuilt monitoring capabilities on the platform, which you install a monitoring agent, and it gives you a lot of metrics and other monitoring data on the CPU utilization, the disk utilization, memory, et cetera, the IOPS, and so on. And in addition to all of this metric collection, you can set thresholds, set alerts, get events via email or Slack when your droplet hits certain threshold levels. We have webhooks so you can connect them into other applications. So that's one aspect that one add-on you want to set up right after you've set up the application. Another is snapshots. So now you have this droplet with the entire stack and you've configured it right and it works. And now at this point you want to take a snapshot to save the state of that droplet so that you can replicate it in the future, or you can build off of that stage. So that's another post-deploy action that we make available. So now at this point, you notice people are coming to the site, they're watching videos, they're uploading videos, and so you're getting to a point where the CPU is almost, it's running high, or the disk's getting out of scale. So at this point, you have an option of vertically scaling these droplets. And what I mean by vertically scaling is scaling a droplet up. Without adding additional droplets, we provide an option for you to live resize that virtual machine for a larger CPU, more number of CPUs, higher memory, and more disk. And at this point, you'll notice that there are we have different types of droplet families. So we have the standard, general purpose, and CPU optimized droplet families, and they all cater to a different type of use case. Standard droplets more for the smaller sized workloads like blogs or smaller web apps. If you want to set up a WordPress site, typically setting it up on a standard droplets recommended. Standard droplets share CPUs underneath. So what that does is that it's typically for workloads that require low levels of CPU, which can spike up every now and then. General purpose and CPU optimized, on the other hand, are more they come with dedicated CPU threads. And so what that means is that these provide the reliability when it comes to CPU processing as and when the application needs it. So in this case, since we're going to be doing a lot of video processing and transcoding videos from the customer's uploading, I would recommend that we go with something like a general purpose droplet, because we also have the web component running on that server, and so we want to make sure we have enough memory and a dedicated CPU to go with it. But again, a lot of different plans. Go into the control panel, select a droplet, resize, and resize up to a larger size droplet. So at this point, we've vertically scaled the droplet up. Now, what if we start running out of disk space? Because a lot of that disk space it hits a certain limit on the droplet. So at that point, now you have the ability to attach additional block storage. And so we provide a service called Volumes, DigitalOcean Volumes. And that is basically an ability to attach external block storage that can range anywhere in size from a gigabyte to 16 terabytes of disk space. And it's all based on SSD storage media. A lot of redundancy built in with triple replication. Automatically formats and mounts the volume. So it's almost as if like you have this additional disk space that's available now on the Droplet. So now we've scaled up the CPU vertically, we've scaled up the memory, we've scaled out the disk space. What can we do next? So just to sort of summarize, we've set up a single Droplet with the entire app stack on it, your entire web server, app server, database, all of the storage. We've configured the domain name on it. We've configured SSL to make sure it's secure, the traffic to and from it. We've set up monitoring and alerting. We've taken snapshots, maybe enabled backups, most likely enabled backups. We've scaled the Droplets vertically to sizes with a higher CPU memory, and we've attached block storage. But now, even after doing all of that stuff, and so something like this can potentially support thousands of users concurrently that are coming to the website. And again, depends on the use cases, how many videos, how many you got to track all of that stuff. But we're going to hit limits in this vertical scaling. So at this point, we have to also, the app everything's running on a single Droplet. It's not resilient. It's that server is the single point of failure. If that server goes down, your entire app goes down. So at this point, we got to think about how to make it more fault tolerant and scale out horizontally. And so that's where a multi-tier architecture comes into place. So in this case, we tease apart the web server and the database. So those are the two main components that we have on our app. And so we split them up and we run them on two different Droplets. And that way, what we have now is an ability to scale those Droplets up and down depending on how much resources are required by the web server component or the database components. Also, at this point, by the way, the deployment of the web server component or the web application or the database can be done by installing those pieces of software on the Droplets, on the virtual machines themselves, or what a lot of people nowadays are doing is wrapping them up and packaging them up as containers and running them as Docker images as Docker containers on the Droplets. So that way, whatever it is that your developers develop on their laptops gets lifted and shifted and placed on these Droplets. So this is a very simple teasing apart of the two architecture. Now at this point, you want to figure out if the database tier that you have is going to be something that's going to be fully managed by a provider, or if you want to set up your own database. And so DigitalOcean provides a managed database offering. Currently, we support the PostgreSQL database engine, and it's fully managed. All of the stuff that comes along with setting up a database and managing a database, including things like daily backups, setting up a redundant architecture with failover nodes, all of the maintenance, data encryption, all of that's handled by DigitalOcean. And so all you do is you spin up that database instance with a failover if you need it, or other read database servers, and set it up with your application. Or you have the ability to run self-managed databases, in which case you have a lot more choice, but then also you have to manage those databases yourself. And also we provide on our marketplace a few different options. And again, you can download and install any database, whether it's SQL, relational, or NoSQL databases. So once you've made that decision, we have the ability we did vertical scaling in the past. We were scaling up and down within the Droplet. Now we have the ability to horizontally scale our application out and introduce resiliency using load balancers. So what you have here is users that are hitting the sharktube.app website or app, coming up to a load balancer. So this is where DigitalOcean provides the ability to identify a certain number of virtual machines and set up a load balancer in front of them, which will balance load as traffic comes in. It'll balance load across the web servers behind it. So pretty straightforward concept. I'll show you how this looks. But basically, what I did was I tagged all our web servers with a specific tag, and set up a load balancer with that tag. So every time we add another droplet and tag it with, let's say, the web server tag, it automatically gets added to that pool right behind the load balancer. And then all of the web servers are communicating with, in this case, a DigitalOcean managed PostgreSQL primary, and then we'll have an option of setting up additional standbys, up to 2 standbys for failover purposes. So now we've introduced a lot more fault tolerance in here. If one of these web servers goes down, the other 2, the traffic will be passed to the other 2. If the primary database server goes down, it'll fail over to the other one, and while the primary tries to heal itself. So load balancers, it's a network load balancing service. It provides high availability with checks. So all of the droplets that are behind that load balancer, we're constantly checking to make sure that they're healthy and they're alive, and we report on that. Automatic failover. So if the load balancer itself fails, there is a failover for the load balancer available while we try to heal the first one. It includes Let's Encrypt support for SSL, HTTP, and TCP protocols, and also proxy protocol support. So as you can see, this is a screenshot here that I took yesterday. Set up 3 different web servers, gave them a sharktube-web tag, and basically they just got added into the load balancer based on that tag. So once we've set up the load balancer, now we have horizontal and vertical scaling and resiliency. So depending on the number of users that are coming in, depending on the load on each of these servers, you now have the ability and the flexibility to scale each of these droplets vertically up and down. For CPU memory disk, you can attach additional storage, or you can scale them out horizontally by adding more servers, more droplets. And so this is a very typical deployment pattern that's used for apps that can literally run into tens of thousands of users that are accessing the app. Another thing you'll notice in here is that we've set up replication for the databases. So you do have a primary database server, but then you're also replicating all of that data into read-only database servers in case you want to spread out geographically to access databases that are just read-only. So with that, now what else can we do? So now at this point, that app can literally scale. It's resilient, it's fault tolerant, it can scale into tens of thousands of users, but there are more tweaks we can do. A lot of the stuff that's provided through the web servers is static content. It's things like JavaScript or HTML pages, CSS, or images, videos, a lot of that stuff. That doesn't really change very often. And so it is a best practice to use something like an object storage service for it, for all of that static content. And so we provide something called DigitalOcean Spaces, which is an object storage service that enables us to that enables you to serve static content like web assets, media, storage, images, etc., to your customers. That service is it's highly available. It's fault tolerant. It's redundancy is built into it. Triple replication in the backend, runs on SSDs, very, very high IOPS, and also it has a free built-in CDN functionality. And so what that enables you to do is sort of get global reach. So what we do is we replicate all of the stuff that's on all of the media files, et cetera, all the static content that you have on the object storage gets replicated on these content delivery networks, CDN nodes around the world. So if your users if your web app's based in New York or Toronto, and your users are in Singapore or Australia, we'll have a CDN there, which will have all of the static content, all of the videos in this case, as an example, that will be replicated over to that local CDN node. And so every time your users try to access the application, they'll be served that content from that local CDN node. A lot of benefits there. One, the web servers don't have to generate all of that additional data, additional content, and serve it. 2, latency issues are solved. Trying to get a lot of data streamed over from Toronto over to Australia will take a lot longer than having something streamed over from Singapore or somewhere close by in that area. So CDNs cache a lot of this data and provide it. Then we have even more tweaks that we can introduce. So we can introduce things in your application like caching. And so caching really, really helps by providing access to data that doesn't change very often within the application itself. Or things like database caching example. So as an example, if your users are running the same query again and again, so let's say they're looking for shark videos off of South Africa or something, and that translates into a query that you run, but that stays consistent. What we can do is leveraging these caches, persist that query, the output of that query, so that the next time someone runs that specific query or asks for those specific keywords, we already have the data cached and we can generate it as opposed to going to the database to pull it. Also, things like HTTP accelerators can be used. Examples are Varnish, Squid, and Nginx that basically allow you to cache a lot of the HTML content and then just provide it to users as opposed to trying to go to the web server and providing it again and again. So huge benefits in terms of performance and scale achieved at the caching layer here. So this is sort of like a final architecture that we've come up with. We have users that are, we've implemented an HTTP accelerator. Behind the load balancer, we have these web servers, and these web servers are delivering a lot of content by connecting to a lot of these databases over load balancers. Another thing that I've introduced here is a message queue. And so far, the application that we've built has components that are interacting directly with each other. So a user asks for the website, it comes to the load balancer interacts with the web server interacts with the database server. A best practice in today's software architectures is to use loosely coupled components. Build them up as smaller services that do a certain thing and loosely connect them together. And so a message queue comes in really handy there. It sort of creates an elasticity between the two components. And as in this case, what this shows is as videos come in and the web or the app servers process those videos, they push them into a message queue, and there are these video transcoder workers behind the scene that are just listening and waiting for those videos and processing those videos and transcoding them, and then uploading them into DigitalOcean spaces so that they can be served. So at this point, this architecture, there's something like this, can scale up to hundreds of thousands of users. Lots and lots of video can be delivered by this. Now, on all of this, so we provide a lot of very, very simple user interfaces to work with all of the services that I talked about, whether it's droplets or spaces or volumes. And we also provide a very simple and easy to use API and a command line interface to work with the DigitalOcean's infrastructure. Very well documented. The benefits being that it enables you to automate a lot of that infrastructure capability, setting up that infrastructure and scaling it out and scaling it in using the APIs or the command line for that matter. Another example is using automation tools like Terraform. So let's say you've set up this entire application and architected it for, let's say, the North American region. And now you want to lift and shift and create that entire thing over in Asia. You can set up tooling using things like automation tools like Terraform to automate the deployment and setup of the entire infrastructure, and then just keep replicating it using that. Very powerful functionality. I talked a little bit about microservices. So this ability to take an application, split it apart into smaller services that do certain things. So in this case, as an example, but SharkTube as an example, you could have a microservice that just delivers the web content. Then you can have a microservice that transcodes, takes all the videos and transcodes and encodes them into different formats. Or you can have a microservice that enables you to share videos or email them out, et cetera, things like that. And so setting up that architecture and then trying to scale it can become a little complicated because there's a lot of moving parts. And so something like Kubernetes, which is a container orchestration platform, comes in handy there. If you can wrap up all of those microservices as containers, then you can deploy it on a software like Kubernetes, which enables you to scale out and scale in across different nodes, your applications. So Kubernetes is a project that was started by Google. It's become very, very popular in the recent couple of years because of the way it enables you to treat infrastructure, sort of abstract infrastructure out and just focus on deploying your applications, and it takes care of scaling out your applications, scaling in your applications, things like that. So what we do is we in fact just recently provided support for DigitalOcean Kubernetes. It's a managed Kubernetes offering. So we manage the entire control plane, and all you as developers have to do is set up worker nodes and deploy your applications on them and scale out. So, but again, this is something that comes, in my opinion, it comes a little bit late. You can architect your application so that it can leverage, it can be packaged up as containers, and you can deploy it according to all of the previous slides that I was talking about, the architectures that I was talking about. But at a point where you're into trying to scale into literally like millions of users, or if you're going to have multi-region deployments and hundreds of servers that you have to manage, something like this will really, really help orchestrate the deployment and scale out and scale in of your applications on Kubernetes. So far we've talked about infrastructure stuff. There are other things that we can introduce at this point. And at this point, it starts becoming, by the way, everything that I've talked about doesn't necessarily have to be done in that order. It's just, these are just blueprints that enable you. You can go directly into a multi-server architecture that's you scale vertically or horizontally as an example. So other things that we can do at this point is look at different types of deployment strategies. So we provide an ability to have floating IP addresses. And what they allow you to do is you set up your application and it's running in production. You have users coming to it, but then you set up a floating IP address in front of it. And so now, let's say you want to make a change to that application, or you're trying to fix some bugs or enhance the application. Instead of enhancing that specific application and potentially introducing issues like regressions or other issues that could affect your production application, what you can do is you can set up an exact replica of that application and make those changes in there. And then using floating IP addresses, when you're sure you've tested that application, it works, the replica, you can just switch over that floating IP address to point to the new application. So that's called a blue-green deployment. There are other types of deployment, I think red, black, canary, many different types of deployment options available that enable you to make sure that any changes that you're going to make in your production application are tested, there are no issues before you start migrating traffic over to that other application. So that's another one. We talked a little bit about that loosely coupled microservices-based architecture. Implementing a message bus at this point, I had that in one of the slides as another advanced concept there. Now at this point, if you're still hitting, if you still have to scale more, you can get into database architectures. Because right now we've just been using a database as a service, or you've set up your own database, but now at this point you can start getting into tweaking your backend database servers. And so there are many different things available. You can do something called sharding, where you partition your data over multiple different databases, and it increases the performance scale of your database. You can split out your databases logically, so you can have a users database, a forums database, a products database, etc. Split it out that way. So those are some of the other things to think about there. So this is actually my last slide. In summary, we've talked about how you can leverage Droplets, which are our compute services, to set up a multi-tier application, scale out those droplets both vertically and horizontally, attach a managed database offering to it for all of your database needs, use spaces for object storage. So all of the static content that doesn't change very often can go into spaces, which is very similar to S3. In fact, it's S3 compliant. So what that means is all of the tooling and code out there that's available for AWS S3 can also be used with spaces. Load balancers enable you to create fault-tolerant architectures, split traffic amongst a lot of backend servers. Block storage enable you to attach additional disks to your compute infrastructure so that you can scale out storage that way. And then we talked about one-click apps, which is a marketplace offering where you have a lot of this stuff, a lot of the software that we have is pre-created, pre-installed, pre-deployed. All you have to do is select a type of droplet to deploy it on, and it'll deploy the entire thing on it. And then we also briefly talked about Kubernetes, which is, in my opinion, a much advanced level concept when you're trying to scale into millions and millions of users. So that was sort of a brief overview of all of the services that we have, how you can scale out your applications on them vertically, horizontally, et cetera, et cetera.